Welcome to Maths for All. I'm Aisling Flynn. This is higher level. This video covers coordinate geometry, that's the line and the circle, and it is exam practice. So I've taken a question from the 2016 Leaving Cert Higher Level Paper 2, and we're going to do questions 1 and 2. So question 1. The points A, B and C are shown on the diagram and their coordinates are there. Find the equation of the line through B which is perpendicular to AC. Okay, so first let's visualize that. We need a line through point B that is perpendicular to AC. So sketching a line here that makes 90 degrees with the line AC. That's what we're looking for, the equation of that line. Let's call it BD. Okay, so here we have a page from our Formula and Tables books on coordinate geometry. We're looking at lines. We're asked to get the equation of a line, so we'll be using this one here. Y minus y1 equals m times x minus x1, and we'll also be using a formula to calculate a slope. So this one here is for slope. We may use it, we may use something else. Okay, so we already said we needed to get the equation of the line that's perpendicular to AC that goes through B. Okay, so equation of a line formula from the Formula and Tables book is this. Now to use this formula we need two pieces of information, a point which we have, which is B, which gives me an x1 and a y1. So those coordinates are 5, 3 given in the question, and we also need a slope for the red line here. And what do we know about its slope? Well, we know that it's perpendicular to the slope of AC. So if we find the slope of AC, we can get the perpendicular slope. So the slope of AC is, we had the formula on the previous slide. You can use the formula with the coordinates if you wish of points A and C, or you can go with rise over run. And so I'm going to do that because it's quickest. The vertical distance between A and C is from -2 to 4, which is the rise, and it's 6, but because the line is decreasing as you go from left to right, it's -6. And the horizontal distance between A and C is from -3 up to +6, which is a total of 9 units. And if we simplify this, we get -2 over 3. Okay, now the perpendicular slope to that is the exact opposite. So you can see the red line, it doesn't have a negative slope, it has a positive slope. And it will be 3 over 2, the reciprocal of the slope of AC, or the slope of AC turned upside down. Okay, now we have all the information we need to fill in the equation of the line formula, which we had up here. So it'll be y minus 3, that comes from point B, equals to 3 over 2 times x minus 5. I'm going to multiply both sides by 2 to eliminate that fraction there, so because 2 divided by 2 is 1, and I get 2 times y minus 3, which is 2y minus 6, equals to 3x minus 15, so multiplying that 3 into the bracket. And now we'll just arrange it in one of the common ways to present the equation of a line. Because I have a positive x here, I'll go with moving everything to the right hand side, so that means I'll have nothing on the left equals to 3x. I'm taking 2y from both sides. I had a minus 15 and I'm going to add 6 to both sides. Okay, so I'm going to get 3x minus 2y minus 9 equals 0. So that's the equation of the line. Let's check the marking scheme. Okay, so presented slightly different. So we got our slope of AC, we got the perpendicular slope, we substituted correctly, and we had ours with the -9 equal to 0, which is correct. Okay, 10 marks going for that. A low partial credit, you can get 3 out of 10 if you had your slope formula and did some correct substitution. Okay, if you wrote down your equation of a line formula and substituted for the x1 and the y1, you can get 7 out of 10 if you got the perpendicular slope correct, or if you used a parallel line, you got 7 out of 10 as well. Use your answer to part A above to find the coordinates of the orthocenter of the triangle ABC. Now, to answer this question, we first have to understand what an orthocenter is. Okay, and we learned this in geometry. So if you have a triangle, okay, the word or the prefix ortho refers to orthogonal or perpendicular. Okay, so in the previous question we saw a perpendicular from one point to the opposite side. Okay, if this process is repeated from each point to the opposite side, so drawing lines that are perpendicular at 90 degrees to the opposite sides, then they should all cross at a single point, and this is known as the orthocenter. Okay, so here's our triangle, and we've already got the line from B, I think we called it to D, that is perpendicular to AC. Okay, things are slightly different in this layout. If I was to draw a perpendicular line from point A to the opposite line, well, I wouldn't find it really possible. I'd have to continue out AC and draw my perpendicular here. Okay, and as a result the orthocenter would be away out here someplace. Okay, but let's not get too concerned about that right now. If I was to draw a perpendicular line from C to the opposite side, I'd have to continue on the line AB, and perpendicular line would be here, and yes, my orthocenter is outside the circle, which is permitted. Okay, so how do we go about it? Well, let me get rid of all those scribbles first so we have a bit of clarity. Okay, so we have our perpendicular line from B to the opposite side. So we need one other. You don't have to do all three. Okay, so one other. If we continue on the line AB, all right, we're going to find the perpendicular line from C to that, and then where this line crosses our BD line, okay, so where two lines cross, this will be my orthocenter. Okay, so for simplicity, let's call this line L. Okay, L1 perhaps, and the line we already have, let's call it L2. Okay, so first things first, we have to get the equation of L1. So again, you're doing equation of a line formula. And as before, we have to find out its slope. Okay, so the slope will be perpendicular to the slope of AB. So let's find the slope of AB first. All right, so A to B, I'm going to do my rise over run. So it's falling, so it's negative slope. It's falling from 3 to -2, which is a total of 5 units. And the run across is just 1, so it's -5. My perpendicular slope then is the exact opposite. It's positive 1 over 5. So filling in y minus y, filling in, we've got y minus, and we're working with point C, which has coordinates of -3, 4. So y minus 4 equals 1 over 5 times x minus -3, okay, which is x plus 3. Now I'm going to multiply both sides by 5 to remove the denominator. 5 divided by 5 is 1, and I get 5y minus 20 is equal to x plus 3, and I'm going to rearrange that like I did previously, x minus 5y plus 3 plus 20 equals 0. And I get x minus 5y plus 23 equals 0. So that's my L1. If you recall from the previous slide, L2 was 3x minus 2y minus 9 equals 0. So here we have the two lines and we need to find where do they intersect. So how do we go about that? Well, simultaneous equations. Okay, so firstly let's set them up nicely. I've got x minus 5y equals minus 23 is how we usually present it for simultaneous. 3x minus 2y is equal to plus 9. Okay, if we choose to eliminate the x's, I'm going to multiply the top line by minus 3. I'll get minus 3x plus 15y equals to plus 69. Okay, and we'll combine that with the second line. Okay, so x's are eliminated. I get 13y equals to 78. And y equals 78 over 13. And when you divide that, you get y equals 6. Okay, and now we'll have to return to one of the original equations, doesn't matter which one. Let's choose the top one because it's 1x. We'll get x, so this is what I'm using here. X minus 5 times 6 is equal to minus 23. X minus 30 is equal to minus 23. X is equal to minus 23 plus 30. X is equal to 7. Okay, and so the orthocenter of the triangle ABC is where they intersect is 7, 6. Let's check our marking scheme. So we have to get the point of intersection of the altitudes is what those perpendicular lines are called. Okay, so we got the slope of AB, we got our perpendicular slope, we got our equation of that line, we did our intersection, which was our simultaneous equations, and there we got that. You could have of course chosen the other point and its altitude or perpendicular line. That's what's down here. So there are 15 marks going for that. You could get a 4 out of 15 if you showed some understanding of orthocenter, even if you drew what it was. If you got some slope formula, okay, and used the altitude for part A. Mid partial credit, so you can get 7 out of 15 if you got the equation of the second line, if you use some relevant substitution towards finding it, or if you did a correct construction. Okay, if you drew it correctly, accurately. And you can get 11 out of 15 if you got the two equations of the lines correctly. Okay, or if you correctly constructed the orthocenter on the graph and you found it through the graph as being 7, 6. Okay, so that was question 1, worth 25 marks. Question 2, again it has the line but also the circle. Alright, a point x has coordinates of minus 1, 6 and the slope of xc is 1 over 7. Find the equation of xc. Give your answer in this form: ax plus by plus c equals 0. Alright, so this is straightforward. It's the equation of a line for which you need one point and you need the slope. We're given the point and we're given the slope, so this should be straightforward. So we'll get y minus 6 equals 1 over 7 times x minus minus 1. So that will convert that to x plus 1. I'm going to multiply both sides by 7 to get rid of that denominator. 7 divided by 7 is 1. I have 7y minus 42 equals to x plus 1. Now let's present it in the form that was asked for. So we're going to lead with the x, positive x if possible. So I'm going to remove everything from the left hand side here, and I get 0 equals, so x. I'm going to take 7y from both sides. I have a plus 1 here already. I'm going to add 42 to both sides. Okay, and so what I get is x minus 7y plus 43 equals to 0, and that's my answer. Let's check the marking scheme. So yeah, okay, very straightforward for 10 marks. Again, you get the opportunity to gain partial credits, 3 out of 10 if you wrote down the equation of the line formula with some relevant substitution. So always write down the formula you're using. And 7 out of 10 if you didn't write it in the correct form. So if you left it as y equals mx plus c, alright? So check that each time. Part B now. C is the center. I think we need to look at the picture for this. C is the center of a circle S of radius 5, and the line L, 3x plus 4y minus 21, is a tangent to S and passes through x as shown. Find the equation of one such circle S. Okay, so problem being here is that we don't know the coordinates of the center here. Okay, now what are we going to use here? Well, the equation of the circle is what we're asked for. Here's our circle page, page 19 in the formula and tables books, and the equation of a circle is gotten by using this formula here, which uses h and k are the coordinates of the center and r squared is the radius. Okay, so we may need that, but in addition we have the tangent to the circle, and we know the distance from the tangent to the center of the circle is 5. We'll look at that picture again, and this might come in handy, distance from x1, y1 to the line. Okay, this one here. Okay, so let's have a look. So there's my question and my picture. So the equation of a circle will be gotten from this. Okay, and we have r, which is 5. We don't have h and k, the centers. Now they're called minus g and minus f here. I think negatives will confuse things. I'm just going to call those h and k. Alright, now we don't have those, so how are we going to find them out? Okay, what else are we given? We're given the equation of the line, which is a tangent, so this L, and we're given this 5, which is a perpendicular distance, so I think that's how we're going to find them. Okay, we saw the formula for that, ax1 plus by1 plus c, the absolute value of that, over a squared plus b squared. Okay, now we know the perpendicular distance from the center here, C, out to the line L is 5, and we get our A, B and C from the equation of the line. So what I'll have is 3, and x1 we'll call h, so these are the coordinates of the center. So 3h plus 4y minus 21 over the square root of 3 squared plus 4 squared. Okay, now in the interest of saving space, the denominator there, I'll just write out the top, is the square root of 9 plus 16, which is the square root of 25, so all that comes to 5. Okay, now multiplying both sides by 5 to eliminate that denominator, because 5 divided by 5 is 1, we get 25 equals to the absolute value of 3h plus 4k, I should be writing there instead of y, sorry, plus 4k minus 21. And what does this absolute value mean? Well, it means the total value of what's inside could be 3h plus 4k minus 21. It could be minus 25, or it could be, the whole lot could be equal to plus 25. Okay, so we've two equations coming out of this. We get 3h plus 4k, adding 21 to both sides, we get minus 25 plus 21 is 4, or 3h plus 4k, we get 25 plus 21, which is 46. Okay, so we've two equations here. Okay, so you think two equations, two unknowns, probably solved by simultaneous equations. But on a closer look, whatever you multiply there to eliminate either the h or the k, what you'll result in doing is you'll eliminate both. It'll be no good to you. So we need another equation. Okay, so how do we get another equation with h and k? So here's our point C. Well, the other thing we have is information for part A. We know that h and k is a point on this line here, for which we got the equation in part A. So perhaps we can work with that. So the equation that we got from part A, that red line, was x minus 7y plus 43 equals 0. Okay, so we can use this in simultaneous equations because hk is an element of it. So if we substitute for x, h minus 7k plus 43 equals 0, we have a third equation. Okay, let's just rearrange that slightly. X minus 7k equals minus 43. Okay, so it really doesn't matter which one we choose. Let's take, we'll call this number 1. We'll use this one here with number 2, the one we've just gotten, and we'll do equation 1 minus 3 times equation 2. And what we get from that is, so let's write down equation 1, 4k equals 4, and minus 3 times, so we get minus 3 times h plus 21 times k equals plus 129. Okay, and then eliminating h, we get 25k equals to 133. Okay, there's something amiss here, and I see exactly what it is. This was a negative 4 back here, minus 25 plus 4, and so this will be negative 4, and so not that. I get 125. Okay, so k is equal to 125 divided by 25. K is 5. Alright, so if k is 5, what is h? So use any one at all. I'm going to use equation 2 there. H minus 7 times k is equal to minus 43. Okay, and we know k is 5, so h minus 7 times 5. So h minus 35 is equal to minus 43. And I'm going to add 35 to both sides. And I get h equals, and the difference there is 8 and minus 8. Okay, so my center, my hk is minus 8 comma 5. So minus 8, 5. And to answer the question that we're asked is to use our equation of the circle formula. Okay, put in the values for h and k. So I get x minus 8 to be squared plus y minus 5 to be squared equals, now my r was 5 squared, and so what I get is x plus 8 squared plus y minus 5 squared equals to 25, and this is my answer. Let's check our marking scheme. Okay, so we used perpendicular distance. Now this solution continues with the minus g and the minus f. Okay, we worked with hk. Did we get the correct answer? Yes, we did, and we got the correct center. Okay, so 15 out of 15 for fully correct. You can get 4 out of 15 if you did some correct substitution into a relevant formula, so any formula. There, perpendicular distance, the circle or the line. 7 out of 15 mid partial credit if you got one of the equations for the simultaneous out correctly. Okay, and you can get 11 out of 15 if you got 2 of the equations for the simultaneous out correctly. Okay, so that was those.